In this video, I'm going to demonstrate the EWSS Pulse Editor. I've already created and loaded a scenario. I'm going to play the scenario, go to the Signal Analysis view, and I want to take a look at the pulses being received by this receiver platform. Down at the actual pulse level, we can see that the pulse is more or less rectangular. If I wanted to modify that pulse shape, I could go into the transmitting platform, select the row of the individual pulse that I'm interested in editing, right-click and open the pulse editor. The pulse editor displays the pulse as in both amplitude, frequency, or phase. Since I want to modify this pulse for amplitude, I'm going to go in here, select amplitude, and I will add what we call pulse segments, which are sub-elements of a pulse. And the interesting thing is that each sub-element of the pulse could be modified for phase, frequency, or amplitude, or time. In this case, I have selected a pulse segment, and I can modify the individual pulse segment like so, or I can apply a modulation to the entire set of pulse segments by selecting a triangular modulation type, starting with a 0 base amplitude and going up to a 1, and you can see that we now have a rectangular shaped pulse being displayed in the signal analysis view. In addition, in the pulse table, I can select the columns and go to type, and we can see the modulation type on this particular pulse row is both AM and it's also a coherent pulse. I'll just take off the coherence and it shows AM modulation type. If I wanted to custom design this pulse to make it look more realistic, I can actually just go in and draw my envelope. Again, if you have too many of these pulse segments, you're going to pay a performance penalty. So it's up to you to decide how much fidelity you want in any particular emitter. So again, the pulse amplitude shape is being shown up in the signal analysis, and I want to now modify this particular pulse for frequency as well. To do that, I'm going to close my signal analysis window, and I've selected frequency under pulse editing, and I'm going to apply linear frequency of 5 gigahertz to all pulse segments. So every pulse segment across the board is now 5 gigahertz. You can see that's also reflected in the pulse table. And I'm going to make the pulse width 20 microseconds. Now to see this pulse, we have to go to a frequency domain display such as we have in the simulation tab, and you can see the signal is showing up at about 5,000. I'll go in here and I'll view our pulse. So in the frequency domain, you can see even at 5 megahertz bandwidth that we have a more or less tall and thin pulse, as you would expect from a single frequency. Now if I want to apply a pulse compression to this pulse, I can select a modulation type of pulse compression. I can go into any one of these dialog elements. If I do set a value in compressed pulse for 1 microsecond, I will get a compression ratio of 20, an excursion of 1 megahertz. If I change the excursion to 3 megahertz, it will change any of the other values, compressed, pulse width, or compressed ratio of 60. I'm going to leave this at a 1 megahertz compression and we should see a difference in our pulse now in the frequency domain. And you can see it's a much wider and lower pulse that's coming in versus what we had before, which was a tall and thin pulse. We can also do the same type of editing with phase. We can do much fewer segments, and we can modify the phase as you might find in phase modulation on pulse type signals. So with phase, amplitude, and frequency, and individual pulse segments also being modified for those three values, we can reproduce just about any type of signal that would be required for simulation. This concludes the demonstration for the EWSS pulse table.